Hello everyone, and welcome to a video on absolute value functions. The absolute value of a number is the distance a number is from zero. So the absolute value of x is denoted with the two little lines there like that. Whenever you don't know how to graph a function, whenever something's new, your backup plan should be to make a table. Making a table is always a valid way. My job this year is to teach you how to recognize functions so that you don't have to make a table every time. But we're going to start this one with a table just to show you that it's a way you can figure things out. So we're going to start with everybody's favorite number, 0. On a number line, how far is 0 from 0? 0 units. How far is 1 from 0? 1 unit. How far is 2 from 0? 2 units. So when you see y is equal to the absolute value of 2, that's saying y is however many units 2 is from 0, which is 2. That's how I got that. If I'm at x's negative 1, then I'm still 1 unit from 0. If I'm at x's negative 2, I'm 2 units from 0. Sometimes kids mistakenly just say absolute values make things positive. And that's certainly a shortcut way of thinking about it. But in the end, understanding what it means will help you for sure. So let's plot these points. 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. And that's what this graph is. It's a V. And I am terrible at graphing without my dots filled all the way in. So I'm going to go ahead and finish my pattern on that side. And then I'm going to finish my pattern on that side. That helps me make a better graph. It's something you might want to keep in mind if your graphs get off. So today we're going to learn how to do absolute value graphs without making a table every time. We do not want to have to do that. So over the last few days, we've been working on linear functions. And I've really been trying to sell you on this concept of m is the slope and then x minus x1. Oh, I just realized I wrote plus h. That's what it's going to be today, plus y1. So this is the slope, and this is any point, x1, y1. Now, for every other graph we do this year, they're going to replace the letter m with the letter a. But it in essence means the same thing. All graphs have some kind of slope to them. So when we learn cubic functions, if it has an a that is large, like 4x cubed, it's going to make it really steep, just like 4x would make a line really steep. But from now on, we're going to use the letter a. But it still has something to do with slope. And for a lot of graphs, what's really exciting is that this HK is not just any point, it is specifically the vertex. So this is more than just, you got a line, you have any point, it's always going to show you that point right there. Okay, so let me tell you about the pieces of this function. K is what's going to determine vertical shift. A positive k means the graph goes up, a negative k means the graph goes down. H determines horizontal shift. So if you see x plus h, that's actually going to go left, because remember, it's the opposite, so it's actually that h is negative. If you see x minus h, that means that the graph is going to move right. The A determines the vertical stretch or shrink. So instead of calling it slope, they reserve slope just for lines. Instead of calling it slope, they call it vertical stretch or shrink. If you have an A that is less than 1, and actually I'm just going to change that slightly because it does also have to be greater than negative 1. In other words, it's a fraction. It's a small number. it's going to make the graph wider. And if A is greater than 1, or if A is less than -1, we'll talk about negatives later, but pretty much if it's a number bigger than 1, it's going to make it narrower because it's going to make it steeper. So wider would be like that if you see something like 1/2, and narrower would be something like that. Your V would be super narrow. A negative A will flip the graph over the x-axis. And like I said before, HK is the vertex of the graph. The graph is going to be symmetric about this line. Remember that all vertical lines have the format x is equal to a number. And in this case, that number is going to be wherever the vertex is. X is equal to h. All right, so let's do some basic problems here. I'll color code them to make our life easier. Y is equal to the absolute value of x. Whenever you see that, you can just memorize these points. You shouldn't have to make a table anymore. So you got that. Got that. Now, if you see a -2 outside the absolute value, then it's going to move it up or down. And what's going to be great is whether or not we were studying x squared -2 or square root of x -2 or x cubed -2. Even when we get there, sine of x -2, every single time it's going to go down 2. So this is going to be great that you guys can have a pattern that's going to work for the entire year. Again, I am a terrible drawer, so I'd have to keep making all the points, and then that way I can just connect the dots. If you can stay on the line, you don't have to draw all the points first. It just helps me. Now, if the extra number is inside the absolute value symbol, that's going to move it left or right. And again, that's going to be true if it's x -3, it's a square function. If it's a square root function, even if it's a trig function, anytime it's part of the actual function, not just tacked onto the end, it's going to move it left or right. But this one's a little tricky at first because it does do the opposite of what you think it would do. So it's going to move it to the right. And the reason for that is you may remember that the actual point is 3. So not -3. So 1, 2, 3. And again, this doesn't have a change in slope, so I can just make my dots at 1, 1, 2, 2, 3, 3. So it makes a V every single time. Okay, now let's look at ones that have different slopes. Again, I'm just going to graph the main one so that you can keep in mind and just keep memorizing what it looks like. Absolute value has its vertex at 0, 0, and then it has a nice slope of 1 on the right and a slope of -1 on the left. Now, if it changes the slope, it's going to be a vertical stretch. The way I like to think of it is that instead of doing 1, 1, it's going to take each of these y values and it's going to double them. See, the y is going to be twice whatever it used to be. So it used to be 1, 1, now it's going to be 1, 2. It used to be 2, 2. I'm going to double that y value. See, double whatever I used to get. So 2, 4. And then 3, 3 is now going to be 3, 6. On this side, -1 times 2 is negative, sorry, this is still +1. +1 times 2, 2 times 2, 3 times 2. And I think I said before, I'm going to keep saying it to make sure we're all on the same page. If this number is greater than 1, it should end up being steep. So the method I just taught you, where you actually double the number, is the safest method, because that's the one that's going to work for all functions that we do all year. For this particular one, because an absolute value graph is made up of lines, some people just think of that number as being slope, and that will also work. Last one. Now let's do it as thinking of it as slope. So its vertex is 0, 0. This one hasn't moved left or right or up or down. And it's going to have a slope of up 1 over 3. Up 1 over 3. So with absolute value graphs, you can think of it as slope, but that won't work for any other equation that we do this year, because none of them are going to be lines except for lines and absolute values. So if you were going to try and do it the way we're going to need the rest of the year, then the method that I use for these is to always write the points I know. 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, still 1, 2. And then I literally multiply them by 1/3 the absolute value of x. So these numbers are the absolute value of x, but I want 1/3 the absolute value of x. So 1/3 times 0 is 0. 1/3 times 1 is 1/3. 1/3 times 2 is 2/3, and so on. And if you look, I'm at 1/3, 2/3, 3/3. So it's another way to think about it. I'm always going to try and give you options, because sometimes people go, oh, now I get it. Okay, let's combine everything. Step 1, plot the vertex. So on this one, the vertex is -2. Remember, it's the opposite of that number, just like for lines, just like for every graph we do all year. -2, 3. By the way, when we do a video, if you ever are thinking to yourself, wow, I totally got this, I want to see if I can do it on my own, I would actually love that. You are more than welcome to pause this video, do all 4 of these graphs on your own, and then just skip ahead in the video, look at the different frames until you see the answers and see if you got them right. Now, if there's no number here, you can literally just start plotting points. 1, 1, 2, 2, 3, 3, -1, -1. You're ready to go. But if there's anything there, then you're going to have to do a little bit of work. So because there's a negative, think of it as a -1, you're going to have to go down instead of up. And I might get off, so I draw all the dots. I know it seems a little silly, but it's the only way I can draw a nice line. Okay. For graph B, my vertex is +2, be careful, -3, +2, -3. And since there's nothing right there, nothing is actually 1. So it's going to be the standard graph, which hopefully you've memorized by now. 1, 1, 2, 2, 3, 3, 4, 4. So you might be thinking, well, you're not actually at that point anymore because you've moved to the vertex. I pretend that this is my new 0, 0. So when I count 1, 1, I'm actually starting here and saying 1, 1, 2, 2, because the shape hasn't changed at all. Okay. Letter C. Oops, that's not the C. Letter C. I'm going to do this one in green. So again, step 1, plot the vertex. 1, -4. 1, -4. Okay, this one has a 2 in it. Now we're going to have to do a little bit more work. Step 2. You might be able to do this in your head, but I'm going to show you how to do it the safe way. Write the y is equal to absolute value of x table. I don't want you to make a table for this function, okay? Not the given problem. Your life is good. You're going to love this method. It's so much easier. So you've got these memorized. 0, 0, 1, 1, 2, 2, -1, -1. I keep doing that. -1, +2. That's the main table for an absolute value function. And then your step 3 is going to be multiply the a. So in this case, a is equal to 2. So I'm going to multiply by 2. I still get 0. Multiply by 2, I get 2. Multiply by 2, I get 4. Multiply by 2, 2. Multiply by 2, and I get 4. And then step 4 is going to be use the vertex as 0, 0, and plot points. Doesn't quite fit. I guess I can just move down. And plot points. So I've got my vertex right there. But now I'm going to pretend that that's 0, 0. That's my first point. 0, 0, right there. I know 0, 0 is really up there, but I'm going to pretend I'm going to use the vertex as my 0, 0. And now from there, I'm going to do 1, 2. 1, 2. And then I'm going to do 2, 4. 2 away from this point. 1, 2, 1, 2, 3, 4. And then I'm going to do -1, 2. So again, I'm pretending this is 0, 0. This would be -1, 2. I just realized I made a mistake. And then -2, 4. And once you see the slope, you could finish making the dots. If you still haven't paused the video, you might pause it now and see if you can do that last one on your own. But I am going to do it with you. Step 1 is the vertex. -5, -2. Remember, that's an easy place to go wrong. -5, -2. Step 2 is make the table. 0, 0, 1, 1, 2, 2. I'm going to go all the way up to 3, 3. I'm looking ahead. I see that 3 in there. I think I'm going to need it. -1, 1, -2, 2, -3, 3. So sometimes you need a little bit more numbers in your table. Step 3, multiply the a. So I'm going to multiply by 1/3. I'm going to put a dot instead of an x so you don't think it's the x in the problem. So multiplying by 1/3, I still have 0. Multiplying by 1/3, I have 1/3. Multiply by 1/3, I have 2/3. I chose that because that's the a. So step 3, multiply the a. And this is why I went all the way to 3, so I could have a nice number. 3 times 1/3 is 1. And then 1/3, 2/3, and 1. So you heard me say during lines, I really would rather you not. It's not that you can't plot fractions, but you can't make your graph dependent on fractions. So here's 0, 0. And remember, these are the old points. I'm actually going to plot 3, 1 from the new fake origin. So I go 3, 1. On this side, I'm glad that I actually did other points because I'm going to go over 1 and up 1/3 because I can't get any further than that. So I'm going to follow this slope pattern to make sure that my line is nice and straight all the way to the edges of the graph. On this side, there's nothing left to graph. So we did 4 examples. I hope that that gave you enough to, now you're going to practice on your own with your homework. Okay, let's do this backwards. So for every single one of these, I want an equation that looks, this could be plus or minus depending on what h is, plus k. Okay? The formula is always written with a minus, but keep in mind that there could be a plus there. I don't want to write the plus in, but it could be a plus. So the best thing to do is the same steps. Find the vertex. This is the point 0, -3. So I'm almost there. I'm going to write 0, -3. All I need still is the a. So keep in mind that these graphs have a slope. Since this did not go 1, 1, 2, 2, 3, 3, okay, that's how I know that a is not equal to 1, because that's what a is equal to 1 looks like. What did our graph do? When we went over 1, it went up to 2. So they must be multiplying by 2. This is your equation. You'll hear me say this every day, all year on these videos. Pause the video. If you can figure out these 4 equations on your own, that would be really terrific. I'm always going to talk them through so that if you get one wrong, you can go back and actually listen to the solution. But your best chances for success in this class is to pause the video, try it on your own, kind of puzzle it out, maybe work with a friend, and then turn it back on if you need it. Okay, all 4 of them. Just to show you that this is the key, do the vertex first. -2, 0. Now that's a negative, so it's actually minus a -2. So my final answer is going to have x plus 2, and I don't really need to rewrite the 0. But I still have to find that a. So instead of 1, 1, so that would be a is equal to 1, I know a is shallower. It's going to be a fraction less than 1. So I look at it, but I don't really know where it is. It looks like half, but I'm not sure. So I do the next one. When they went over 2, they should have been at 2, but they were only at 1. So what did they do? They cut it in half. That's your equation. Next one. Find that vertex, 1, 3, and put it in your equation. X minus 1 plus 3. I love these things. I really do love them. And now, again, you have to figure out what they did to get this. It's definitely going to be a fraction because there's a is equal to 1. It's much shallower. And how did they get it? It would be really nice if you could puzzle it out, but you really don't have to. Instead, you can just say, oh, I can see that the slope is down 1, back 3, down 1, back 3. So it has a slope of -1/3. It is a slope, so go ahead and use that fact. And the last one, y is equal to, start by finding the vertex, y minus 2. Oh, I don't know why I put a y. No one's here in the room to yell at me. X minus 2 minus 3. We just need to get that a. Little bit tricky. Sorry that. Oh no, no, come back. There it is. So this one is definitely a little bit trickier, but luckily you still have the concept of slope. So keep going until you find a good point. There's a good point. Okay, don't try and figure it out here or here. So it went up 3 and over 2. Okay, that's your slope. There we go. We did it. We got all 4 done. Now it says, graph the above graphs on your graphing calculator to check your answers. So that's what I would have done if I hadn't walked you through it when we were if we'd been in a normal class. I am going to do a graphing calculator lesson. So there is going to be a graphing calculator lesson, but I'm going to put on a separate video. And I will use these as some of the examples. but you can look for it on the drive where all the other videos are. Okay, there's 2 word problems left. It says, the front of a camping tent can be modeled by the function. So you know it's some kind of a V shape. This is a kind of a weird problem, but what they mean is you have a tent that looks like this. Tents actually don't really look like this much anymore, maybe still some army tents, but people have a lot of cooler dome-shaped tents now. But let's just say that this is the front of your camping tent. So it is a negative, because see, there's the absolute value. It's going down, and it's been moved over from the center. So what is the vertex? Are you sick of this yet? This is always the question. What is the vertex? But hopefully that means you've learned it. 2.5 and then 3.5. So it's in a weird spot. And what's even weirder is this really awful slope. And you're thinking, I don't even know how I would use that slope. So that slope, negative 1.4, can be thought of as negative 14 over 10. 1.4 is 14 divided by 10. And then, this is very complicated. This is what makes this class honors. Don't do this. I don't do this problem in non-honors. I can reduce that to negative 7 over 5. And then you can think about that as it's going to go down 7 and over 5. But you might be thinking, my graph is too small. I can't go down 7. But slope is a ratio. You can go down at however much you can go down. So if you can't go down negative 7 over 5, go down halfway. Go down half of 7 and go down, or go over half of 5. They were very tricky on this one. So down 3.5 and over 2.5 would actually put you right there at 5. And in the other direction, down 3.5 and over 2.5 actually puts you at 0, 0. So they were a little tricky. I'm not going to give you one this hard on a quiz, but you can be thinking about this as the tent, and there's the grass. Okay, we're just looking at that. So graph the function, we did that, and interpret the domain and range. So the domain of something is all the things, that's terrible. I'm a perfectionist, I gotta fix it. All the things that X can be. So on my graph, you can see that the graph only goes from 0 on the x-axis until 5. So we call that the domain. In the actual function, if you were making a table, you could pick any x you want to, but in the given context, x is always going to be between 0 and 5 because the tent does not go below ground. Range is all the things y can be. And in this case, the lowest number it ever comes out to be is 0, and y is in this direction, it's vertical. How high does it get? It goes all the way until 3.5. That's the range of this graph. So they gave a pretty tricky problem here, but hopefully it gave you a little concept of workaround for a slope that might have been hard, and we gave us a chance to talk about domain and range. Last problem, folks, you're almost done. While playing pool, you try to shoot the 8-ball into the corner pocket. Imagine that a coordinate plane is placed over the pool table. The 8-ball is at 5 and 5/4, which is also 1 1/4, if that kind of helps you. So 5, and then 1, 2, 3, 4, 5 1/4. It's not an exact point. It's hard to graph. The pocket you're aiming for is, oh, hold on, that's 1 1/4. I just did 5 and then just 1 1/4 right there. The pocket you're aiming for is at 10 5, way up here. Okay, so here's your 8 ball. You're aiming for this pocket. Okay, but instead of shooting it right in, if you know anything about pool, a lot of times they bank the ball off the side and then shoot it. So this person says, you know what? I'm going to bank it off of 6-0. So they're going to take the 8 ball and they're actually going to hit it from that direction. So they hit the ball, it banks off the side, and then hopefully goes there. And their question is, if you do that, if you're able to hit right at that spot, will you actually make the ball go in the hole? So this is the side of the pool table. This is another side, and this is the hole that you're trying to get it into. So this is the way that it's normally played. Well, let's start by finding the equation for this. So y is equal to, I can see the vertex is at 6-0. I need to know the slope. So the slope is up. I'm not going to use that point because it's a hard point. I'm going to use my 2 good points. So up 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5/4. I've written the equation. The question is, if I actually use that point, is that point on this, is it on this V? So when you're playing pool, it actually does follow the absolute value function. If this is the path, then you have to hit it on the like path. So let's look. Is 5/4 on the same path? I'm going to call it a path, but that path is the absolute value function. So how do you know if a point is on a line or on any function? You just plug it in. So 5/4 is equal to 5/4 times x minus 6. Oops, I know the x. 5 minus 4. So I'm putting the 5 in for the x and the 5/4 in for the y. It's not a 4. Plus 0. 5/4 is equal to 5/4 times the absolute value of -1. The absolute value of -1 is 1, and 5/4 is equal to 5/4. So yes, that was a good place to bank it. You are going to make that shot. So the absolute value graphs are a little bit tricky. So remember our plan for homework. Now that you're watching the videos in class, you don't have to do every single problem on the homework on your own. What you're going to do is you're going to take your worksheet. Remember, we won't normally be doing a worksheet. Normally, we're going to be working from the book. This is your last day for a worksheet. But you're going to take your worksheet and you're going to do every single problem that you can, just to get them all done, as many as you can. And then you're going to save anything that you get wrong. If you get it wrong, the answers are right on the worksheet. If you get it wrong, if you're struggling, don't struggle. Those are what you're going to bring into class or on Zoom, and you're going to get your questions answered there. Okay? So thanks for listening. This was your first video. I would love your feedback. If I went too fast or too slow or wasn't clear, make sure that you let me know. I want you guys to have a great year. But I'm hoping that instead of doing exactly what we just did in class and then sending you home and hoping that you understood all your homework, I hope that you can get as much of your homework done, but then you'll be really comfortable saying, oh, I can't get that one. I'm going to ask about it in class. And we can use that class time really wisely. So Have a great day, and I will see you on Zoom or in class.